Hello and welcome back to the channel. Hey, I'm Ron with Ideal Industries, and in this segment we're not going to talk about low voltage products or datacom products. We're going to talk about Ideal's electrical digital multimeters and testers that you might find out there from us. Now, in this group of product, what these are what I kind of consider our entry-level type testers that really just about anybody can afford. You'll spend 20 or 30, maybe 40 or 50 or maybe even $60 in a tester like this, but these are great for the homeowner and the hobbyist and even the entry-level type pro person. And so if you're looking for doing testing around the home, these are great testers. And in this segment, we're going to talk about the 61-340 over here, which has some additional features to the other testers we've already talked about. I'm going to walk you around the dial here as well, so let's take a close-up view. Here we have a close-up view of the Ideal 61-340 digital multimeter. And the digital multimeter has obviously a LED display on it that we'll obviously take some readings with here in a minute. I see several function buttons here on the top we'll play with as we go through the tester. You see that dial itself, and of course you see all the functions that the tester will actually measure, and we'll walk you through the dial. On the bottom of the tester is where the test leads go in, and you see several openings here. We'll show you how to where to put the leads. And then on the very bottom of the tester, I want to point this out. It says 600 volts. AC or DC, it will measure up to 600 volts, and it's what we refer to as a Category 3 tester. Now, this category rating tells me where I can safely use the tester. Category 3 testers can be used in electrical distribution panels, like your breaker panel. They can use in feeder circuits as well as branch circuits. Also, appliances, also, low voltage applications. So, in many applications, this is a tester you might be looking for, especially if you're more of the pro guy that has to get into electrical breaker panels, or I am electrical contractors. So, this is a great little meter. Now, these are auto-ranging type testers, and we'll get into that in a minute, but this tester has several ports to it, and one of them is this black one. And the black lead always goes in that one, okay? Look at the two leads that you're given. Now, the red lead can go in any one of these other 3 ports based on what you're trying to measure. Keep in mind, you got to have it in the right hole to make the right measurement. And this opening over here above it says 10A, indicating 10 amps. And so the tester will measure up to 10 amps in that, if I have the red lead in that opening. AC or DC, by the way. This is microamps and milliamps, so if I'm measuring small amounts of current flow, I'd have the red lead in there. And right below that is the temperature, which is Fahrenheit and Celsius. So I'm going to put my thermocouple in the tester. It will be across the common and the temperature, and we'll show you that in a few minutes here. And then on this one over here, you see a V symbol for voltage, a mega right next to it for resistance. The symbol right next to that is a diode. The audible symbol on the far left, hertz in the middle here meaning frequency, and of course the capacitor symbol are next to it. And the red lead in most cases is in this setting. Now, anytime you use a meter and you turn it on, you want to make sure the meter's working properly. And the way we'll do this, we're going to take the tester and move over to the dial to the omega symbol here, which is measuring resistance in a circuit. And it's showing me mega ohms, meaning it's seeing it says OL, meaning overload. It sees so much resistance it can't measure it because it's an open circuit, or my test leads are not touching. Now, if I take my test leads and touch them, the tester is going to go down to 0 or pretty close to, and basically it's telling me, hey, the tester is working, my test leads are good, and it's safe to use the meter. Now, that's one of the first things you always want to make sure the tester is working properly. So to do that, now you'll notice on the tester is a little audible symbol right below here, and if I hit the select button here, you'll get an audible symbol here on the top of the tester. And the tester now, when I do that same thing, the tester beeps at me, making an audible tone, indicating that the tester is working and I have good continuity across whatever circuit I'm testing. So I don't even have to look at the meter to see if it goes to 0. I just listen for the audible tone. And that's a handy feature to have when we're testing the continuity across things like this old single pole switch. And this single pole switch is pretty old, but it still works. And if I go across the 2 terminals on the switch and I get absolutely no reading with the tester, meaning it's seeing an open in the circuit, well, obviously the circuit's open. So if I throw the light switch, the circuit should be good now, and the tester's going to go down to 0, and it's giving me that audible tone that I'm looking for. And so again, I don't even have to look at the meter. I just listen for the audible tone, and we double check to make sure that light switch is actually good. Now I can actually do that to measure things across the fuse as well. If I want to see if the fuse is any good, and I go across the fuse, and the testers drop it down to, looks like down 5 or 6 ohms here, maybe down into 4. And the tester's beeping, telling me it's good, and I'm actually measuring the resistance of that fuse, and of course I should see something there. And of course when I don't have the testers leads touching, again, it's it's an open circuit. So there's a handy couple functions right there. But before we do the other two in that one, I want to drop it back down to the voltage function. And let's measure some voltage, and I'll show you what these buttons across the top of the tester do. And in this case, I have it in V with the squiggly line above it, which means AC voltage. And sure enough, the tester over here says AC. It's measuring millivolts, and it is measuring a little bit of voltage here, which is just the electromagnetic fields being generated around all devices will have something here. So but it's very small amounts, thousandths of a volt. Right there it says APO. It means auto power off, and there are times when I'm measuring things that I might want to turn the outer power off, okay, and we can do that. And then the auto range, meaning it's auto ranging, and I don't have to have it in a certain setting for voltage, meaning 10 volts, 100 volts, 1,000, 600 volts, whatever, 1,000 volts. So it's in auto ranging, and if I want to measure the voltage in a circuit, I can take my little extension cord here, go across that, and it's measuring, about 120 volts or 120.4, 0.3 volts there. Again, it's AC voltage there. And it's in auto ranging. And of course, if I take my test leads and reverse them in AC, you're going to get basically the same reading. Okay. Now, you'll notice the range button on top here. If I hit the range button once, it's turned the range off. And it's still giving me the same reading, and it's in the proper setting it needed to be in. If I hit the range button again, it goes into reading for thousands of volts, and you notice the accuracy of the meters went down a little bit, and it's reading 118 ohms, or 118 volts, I should say. And I hit that range button again, it's going to try to measure millivolts, but I'm seeing hundreds of volts here. So obviously that's too low of a setting. The tester says overload, it can't read it because it's in the wrong setting. I run it on the next one, that's like 1 volt, and that's, again, not hitting it. And the next setting is 10 volts, and the next setting is into the 100 volt range. And so now I'm reading the reading I wanted to again. And if I take the range button and hold it down now for 2 seconds, it's going to turn this auto range back on, and it's back into auto ranging. So you can take it in and out of the ranging function if you care to. Now the frequency of the Hertz button here, if I hit it once, it shows me Hertz here, and it's measuring me the frequency of the AC waveform, which should be pretty close to 60 Hertz, and it is. Now, if I happen to have the tester in this setting, which is Hertz, and I'm going to take the test leads out, and I'm going to run it over to Hertz. The tester is now actually more sensitive, and it is able to measure literally thousands of hertz, okay? And you will see here now that the dial's fluctuating quite a bit on me. And you'll find that in all AC circuits, there'll be noise or interference on the AC waveform. So it's not a clean looking AC waveform. And all harmonics in a building can cause this to happen. And any power switching supplies, basically anything with a microprocessor in it, can add to this whole little harmonic or noise problem in a building. So the tester's got to be able to filter it out. But in electronic circuits, we might want to measure hundreds, if not thousands, of hertz. So in this setting, the tester is very sensitive to frequency. And if I take the test leads back out and turn it over to just regular voltage here, and take that measurement, and then hit the frequency button here, it's actually got a filter that will filter out a lot of that noise. So now again I'm measuring pretty close to 60 hertz, which is what I want to be measuring. Now the duty button here next to it, I hit this button again, and it goes to percentage. And when you look at an AC waveform, it'll be in a positive state at some period of time and a negative state at a certain period of time. And you want it, 50% of the time it's in negative and 50% if it's in positive, and that's exactly what this is doing here. So it's showing us 50% duty cycle, which was what we would want it to see. And again, in industrial circuits, you might need to measure that. And again, if I hit that again, it's going back into measuring just regular voltage for me again. Now, there are the min and max buttons here as well. And if I hit the max button, you'll notice that it's saying max, and it's going to measure the max voltage it sees. And if it saw a higher voltage, and if I disconnect the lead, it's going to hold it. If I plug it back in, it might give me a little higher voltage, maybe. No, yeah, there it is. It'll give me a little higher. There it goes a little higher. It's giving me the highest voltage, so it's going to hold it. And you notice it turned off the APO, the outer power off function of the meter, because there's times when I might want to leave the meter sitting here for a while to actually measure the max it might see over a period of time. And of course, if I hit min, it's going to give you the minimum it sees. Okay, and in this case, very low amount, because again, the AC waveform is fluctuating quite a bit. Okay, and again, if I hit that back off, it goes back to min, and if I hold it down, it goes back into the outer power off function, and I turn that back on. Okay, now, and I could have done that with the hold button. So say I disconnect this, and if I want to hold the last reading I see, so if I plug the test lead back in, I hit the hold button here, and hit it, and you'll notice above here it has the hold symbol kind of lit up on the LCD screen. I take the test lead out of the outlet, and it's holding the last reading it saw. Not the highest, not the lowest, just whatever happened to see the last time it was plugged into it. You'll also see next to that hold button kind of a symbol indicating a light bulb. So if I take this button and hold it down for a couple seconds, it actually turns on the backlight in the meter. And so if I'm in a dark environment and I need the backlight, I can turn the backlight on through that. And if I hold it down, it turns. Oops, I didn't turn it back on. Okay, all right. So it's all back off again. Okay, so again, we're measuring DC with this, or AC with this. Now, if I want to measure DC, I would have the test red lead in the same spot because I'm doing voltage, but I then would take the tester and measure the voltage with the straight line and the dotted line underneath it, which is indicating DC. And the meter says DC, it's on auto power off, and again, it's on auto, and we're measuring millivolts here. And if I wanted to measure, say, the DC voltage of this battery, I could hit the test leads across the battery. And the tester's showing me about 9.67 volts DC. Now, with DC, of course, there's always AC and positive with the test leads. And of course, the red lead's supposed to be positive, and the black lead's supposed to be negative. If I accidentally take the test leads and reverse them on the battery, you'll see it's giving me a negative 9.67 volts, basically, which basically says, hey, basically, I just have the test leads in the wrong spots. And again, if I reverse that, it'll go back to a positive reading. Okay? Now, there's a button on here I didn't show you earlier with the AC, but you notice the button says REL, which is relative. So, say I want to know the difference between two different voltage sources. So, in this case, two different batteries. So, if I hit the relative button, you're going to get a symbol on the top of the tester, that little triangle, and it's going to take the voltage in this first battery, which was 9.67, and actually hold it and store that. And then if I take a different battery and test it, and put my test leads across it, it's showing me 0.17 volts DC, and that is the difference in voltage between the two batteries, and it's a positive number, indicating that the second battery actually is a little stronger in strength. So I've actually measured the difference in the batteries. So that's my relative voltage I'm measuring to, and I can take a third battery and see how close it was to the first battery. And that's what the relative button's going to do for you. And so if I'm comparing voltages or different things, that's where I might use the relative button. If I hit it, it should turn it all back off. Okay? So that's the cases where we're measuring some DC voltages. Okay? Now, if we take the meter, and let's go into the ones we didn't cover. We really didn't cover resistance properly here. We just talked about the test where we'd actually measure resistance, and we can measure resistance in a lot of things, between motor windings to wires, or we just want to check to make sure things are working. So here is a resistor on this board, and I'm going to actually measure the resistance of it. So I'm going to take my test leads and go across it. And the tester is, again, in auto ranging, and it's going to show me 180 ohms. And again, if I hit that range button, it would take it out of that setting, which I'm going to leave it in that setting because auto ranging, I think, is the best place to put it. Leave it. And the resistor is good, and it showed me it's about a 180 ohm resistor. Now, we've got two of these resistors side by side, and they're actually wired together in what we call series, or end-to-end, so to speak. And any devices that are wired in series, you'll basically take the resistance of the two devices and add them together. In this case, they're both 180 ohms, and the tester is reading about 360 ohms, which I would expect it to read with 280 ohm resistors wired together in series like that. So there's an indication where I actually measure the resistance of a device if I needed to. Now, the tester in this setting has several functions here, and if I want to hit select button here, I get the audible indication on top. Again, if I'm checking the audible symbol, if I hit the select button again, it goes to this diode setting. So again, I just hit the select button there. And I then can double check and check to see if a diode's any good. And the little black device on my board is a diode. And a diode is a device that is used in all kinds of circuits, by the way. And it is a device that only lets current flow through it in one direction only. So if I take my test leads and go across the diode, it's going OL or overload. In other words, I can't read anything here. Diode is open, basically. I don't see anything here. If I take my test leads and reverse them on a diode, and now I'm getting some form of reading. I'm getting about a half a volt here through the diode. That means the diode is good. It's only actually working in one direction only as I get the test leads. Now, if the diode gives me an OL in both directions, it's bad. And if it's OL in one direction and I get 0 in the other, well, then that's a short in the diode. So the diode, again, is working if it's operating in only one direction only. Okay. Now, another function we have here while we're in this setting is this capacitance function. So now I'm going to hit the select button. And the tester over here says NF, meaning nanofarads. And we are actually going to measure the capacitance of a device. And this little blue thing on the board is a capacitor. And a capacitor is basically a device that's going to store an electrical charge. And it should hold it over time. And there's a couple ways of measuring capacitance, but what this tester is actually going to do is it's going to charge the capacitor up, and so it's going to take a few seconds to do this, and then it's going to hold the capacitor charge over time and actually measure the fact that it is holding it over time as well. And you'll notice that it's kind of set up, and it's running 138.8 microfarads there, and it might fluctuate a little bit more at this point. But that's basically about 140 microfarads there. So it's going to take a few seconds, and depending on the capacitor you're measuring, it may take 20 or 30 seconds, and occasionally even maybe 40 or 50 seconds, but usually within a minute it's charged up that capacitor, and it's making sure, again, it's holding its charge over time. So here's an example where we might actually measure the capacitance of a device. And again, you'll find capacitors in all kinds of things, and all your ceiling fans, any motor would have basically a capacitor in it, okay? Now, we've already mentioned the frequency setting earlier, and again, if I'm measuring very high frequencies, like in electronic circuits and things like that, I might have the tester in that setting. Again, the red lead being in the same spot down here on the bottom of the tester. And I'm going to skip over the frequency setting for a minute and run over to the amperage settings here. Now, when I measure amperage here, again, we got microamps, milliamps, and regular amps here, AC or DC. Now, before you put the tester, rotate it in this thing. We've got one problem here. Is this red lead down here is not in the right setting. You notice it's in the V for voltage, omega, capacitance, hertz, the audible tone, but it is not measuring AC or DC amperage. And I'm going to measure milliamps, so I'm going to take this test lead, move it over to this other setting, and now I can measure AC or DC milliamps or microamps of current. So now I'm going to take the tester and run it over to milliamps, because my little printed circuit board, I can actually take a battery here and plug it into the circuit board. And I'm going to actually light up this little LED light you see on this and make this tester part of the circuit. And the tester is going to be measuring DC amperage, and we're measuring milliamps. And by the way, if I hit the select button, it would go to AC amperage. But in this case, we're doing DC. Okay. And on my test leads, what I'm going to do is I'm going to take some little alligator clips and clip them to the test leads. And to measure current with a digital multimeter like this, you've actually got to make the tester part of the circuit. And so the current's actually got to flow through the meter itself. And it is in this case. And we're measuring some milliamps of DC current flow through this little printed circuit board. And you notice my little LED light over here is lit up. And I'm pulling about 6 milliamps of current through the printed circuit board. If I turn my knob up, that current flow is going to go up. You'll notice that LED bulb is getting brighter. And if I crank it all the way up, it's flowing now about 20 milliamps of current. My little bulb there has gotten pretty bright. And I can measure again milliamps of current. But you got to understand the tester's got to be part of the circuit in order to measure current flow. So if I take one of the test leads and disconnect it, that little bulb goes out, and we've broken the circuit again. The tester, it got nothing. And again, when I reattach it, again, we've got current flow through the meter again. And so that's one interesting thing when we're measuring current. The current actually has to flow through the meter. Now, if you happen to have the tester, and you've got the red lead over here, and then you switch the knob, and you accidentally measure either AC or DC amperage, or voltage I should say, but because you have the red lead in this amperage setting, not over here, what's going to happen is you're going to blow the fuse inside the meters. And they will no longer measure amperage. Either the milliamps or the regular up to 10 amps. There's two different fuses in here, so depending on which one you blow, it will not measure that amperage anymore. So the tester still works on all these other functions. We no longer can measure amperage. So keep that in mind. If you ever blow the fuse in the meter, you'll have to take the back off the meter and replace the fuse, so it's not actually hard to do. And there are instructions on how to do that on Ideal's website. Now, the next thing I want to do with the tester is what we haven't done yet is temperature. So I'm going to take the black leads, or the leads, completely out of the tester because we don't want to measure, we need to measure temperature, I should say. And the tester came with a thermocouple. And when you look at the thermocouple, there is a positive and a negative symbol on the thermocouple here. And we got two ports that can plug into the meter. Now this is actually bad because the negative one's on the regular side. It should go line up with this black port, so we make sure we install the thermocouple properly, and we'll take the tester and we'll move over to temperature, and it's measuring the temperature here in the room, and it'll take maybe a few minutes here to kind of settle down, but eventually it'll drop down probably a little bit. And with all the lights here in the room, I'm not surprised it's not a little warmer. And of course, if I touch the end of that probe, it should go up in temperature, and should continue to go up. But again, it's measuring the temperature in Fahrenheit here. And if I want to change that, I would hit the select button, and now it's giving it to me in Celsius. Okay. And there I go about measuring the temperature in a room with the temperature probe. And if you need to ever calibrate that, again, that's on Ideal's website. If you need to make sure that say you've changed thermocouples here and you've gone to a different version of it, you might have to actually calibrate the meter to make sure it's as accurate as you want it to be. And the tester has some other couple basic features. I turn it all the way off on the back here. There is a little stand so you can stand it up if you care to. We can remove the rubber boot on the tester if we have to. And on the back here is a battery compartment if we have to change out the batteries. And of course there's screws in the very back here that we can remove where we need to get inside the meter and actually have to change a fuse out if one has to get replaced. And there you go. That is the Ideal 61-340 digital multimeter, and thanks for coming to another segment. And this one we did obviously testers and meters. And again, my name's Ron with Ideal Industries, and I'll plan on seeing you next time.